more people filter on in, we'll go ahead and probably get started because there's a lot to cover that I wanted to plan to cover in this 20 minutes. So my name is Wade Rochelle. I'm a distinguished architect at Ironbow. I'm excited to kind of spend some time with you all to talk about some of the innovations that are going on in the WAN space. I know within the DoD, I've been working with many of the male devs, and it seems like some of the high priority initiatives are around WAN transformation. So with that in mind, I hope that some of this information will be beneficial to you all of what's industry, where industry is going, and some of the work that we at Ironbow are doing with some of the big OEM partners that we have. And also I'm going to share some use cases of where we're actually implementing some of the things I'll be talking about within the DoD. So I just kind of wanted to start out with kind of the problem statement. And this is really what we're seeing. It applies to the federal government, but it also applies to just industry outside the federal government as a whole. Is for very large enterprises, as you see the cloud coming into the picture, applications are more distributed outside of kind of a centralized location or data center of an industry, of a company. There are large enterprises are having to deal with lots of different WAN technologies. And I was actually about 4 years ago doing an evaluation for one of the MLDEPs, and they had 4 different overlay WAN transport technologies implemented. All of them siloed, all of them using different protocols. So it was tough to manage and operate, right? There was nothing unified about it. So that has been an issue that's been out there. Again, you're talking about smaller customer sets. You don't see this as much, but the big enterprises, and I consider the MLDEPs and the DoD being a big enterprise, this is definitely an issue because we have many different WAN technologies and solutions implemented within your enterprise. You know, you have to stitch them together. There's a lot of operational overhead to do that. Lots of knowledge that your operators have to have with the different technologies and protocol sets. So part of what we're going to be talking about, how to simplify that problem set. But to do that, I wanted to kind of talk about 2 of the prevalent WAN technologies that you kind of see that can be defined as kind of software-defined WAN technologies. One I know that you all are very familiar with, which is your traditional SD-WAN. That's been heavily marketed within the DoD space. But one that you might not have heard of very much is segment routing, particularly segment routing over IPv6. So you might think, oh, isn't that a service provider technology? And I'll kind of address that here in an upcoming slide. But both of them are great technologies to implement within your WAN, within your enterprise WAN. But both kind of serve different use cases. And what I've seen with customers, particularly bigger customers, is traditional SD-WAN has been marketed heavily. It's a great technology, particularly at the edge. Sometimes can't fulfill all of the mission requirements when you're talking about using that as a transport. And that's where SRv6 can come into play. Another issue with SD-WAN is I know a couple of the agencies are evaluating multiple SD-WAN vendors at this point in time. With how the IT kind of decision making is sometimes distributed within the MLDEPs, there's a good possibility that you could have a MLDEP have 2, 3 different flavors of SD-WAN in their enterprise. So one of the things with traditional SD-WAN is that they're typically very proprietary in nature, particularly the control plane. So how do you unify those, provide a true JADC2 platform for your enterprise and unify those? And so that is kind of another problem statement that we're trying to solve with this concept that I'll be talking about with a software-defined unified transport, which I'll show you a slide here in a minute, but it's the melding and the integration of both SD-WAN, where it's the right place in your environment to implement that, and then SRv6. And that's where some of the innovation I'll be talking to you about today. One of the things with SRv6 is, as you kind of see here, SD-WAN is an overlay technology. You don't have control of the underlay. And if you're doing this in an enterprise environment, maybe if you have different solutions for tactical enterprise, there's a stitching that has to occur. With SRv6, segment routing over IPv6, it is extremely scalable. And it also provides you a homogeneous and unified overlay and underlay that can provide you a lot more granularity of how you make routing decisions for your missions. So I wanted just to quickly kind of give you, and come visit at our booth at 2003, or get to me afterwards, or go ahead and reach out to us. There's a lot to cover of how SRv6 works. This is going to be a really short little primer. So SRv6 is basically a source routing technology. And there are kind of two variants of segment routing. One is segment routing with MPLS. It's kind of been a transition. It's a transition mechanism in many cases to go from your traditional MPLS to start adding in segment routing capabilities. And then there is where you really get the bang for your buck with it is with SRv6 over IPv6, or segment routing over IPv6. That's where you can get the true programmatic nature and all of kind of the SDN capabilities with SRv6. It uses a 128-bit address, SRv6 or IPv6 address, and you can embed in that address encode the hops through your network. And that can be done programmatically from a software-defined controller. And you can do that from a single pane of glass. So it's very powerful, it's very scalable, and it can operate at very high bandwidth speeds. So as I kind of mentioned, a lot of people kind of don't consider SRv6 because they consider it a service provider type of technology. One of the cool things about SRv6 is they greatly simplify the protocol stack from traditional MPLS. So if you look at here on your left-hand side, the number of protocol shems that you have to put in sometime to implement some of the, especially the inter-domain MPLS routing capabilities that you see in the DoD everywhere. GRSS uses a flavor of MPLS in which you're having to stack all sorts of different labels together. Very complex, hard to, sometimes can be hard to operate, and it's hard to be able to use a software-defined controller to build that. And as you see the different iterations of segment routing, particularly SRv6, what you see is a huge simplification of the protocol stack. So it's a lot easier to consume for operators. All you need to know is IPv6 and BGP basically. And it can be programmatically controlled by a software-defined controller. So you move towards needing to be a CLI jockey to now being able to administer routing policies and configurations from a controller and have that automated within your SRv6 platform. So where's this being used today? So SRv6 has been implemented across about 25 different hardware vendors, and it has had 5 years of implementations. It's been heavily implemented in the Asia-Pac domain. Within the United States, it's been a little bit slower to be implemented. I think the service providers are trying to get as much out of their legacy MPLS networks. But even within the United States, you're seeing them starting to adopt this technology. It's also being used right now in the federal government. So if you're familiar with Space Force's transport, that is a segment routing transport. It's been implemented in AFRICOM. Those are kind of the earlier implementations of SR with MPLS. But U-Safety has a mission network that's MPLS, that they are modernizing to SRv6. And we here at Ironbow, in partner with Cisco, are working with PACAF here in the Pacific to implement a new mission network codenamed Project Phoenix, in which we are implementing SRv6 as a mission transport. One of the cool things, I was at Rocky Mountain Symposium this past year. There was the A6 commander for U-Safety in the room and the PACAF A6 commander in the room. And because of the scalability of SRv6, and you don't have to worry about stitching discontiguous, siloed WAN transports together, it's unified across the board. It's very easy to federate with other mission partners, with other agencies with SRv6. So they were looking to federate their two mission networks together, so that as possibly the flight from Europe moves over to the PAC, they can easily move their cyber assets over this transport. And so that's kind of cool. And also Mesh1T, the Space Force Transport Network, has interest in joining as well. So this is a great technology to be able to provide a true JADC2 unified transport, to be able to federate with other agencies, with other missions and mission partners. The other, I think, key thing to note, I wanted to make sure that I share with you all, is it is a multi-vendor solution. I've been working with several of the MEL devs. They've been going through some big initiatives around trying to implement software-defined WAN solutions and have it be, utilize the concept, the principle of SDN of openness and being multi-vendor. SRv6 is a technology that will allow you to do that. There's actually an international testing consortium for SRv6 called an EANTC. They do a report every year, taking all the implementations of SRv6, testing it together, all different types of variety of use cases to make sure that it is truly a multi-vendor solution and technology. Here's the link right here. Take a picture of it, but you go there and read this last year's report. You see all of the different OEMs in there that they test against. So you can federate with a particular agency that's running Juniper and one that's Cisco, and it would be a unified network, and you wouldn't have to worry about any type of issues with any type of proprietary things not allowing them to integrate together. So given that quick little primer, this is kind of the gist of what I wanted to kind of talk about, the true innovation that I wanted to show you all. It's this concept of a software-defined unified transport, which is really the coming together of different software-defined WAN technologies together to provide an end-to-end integrated platform, where you might have SD-WAN at your edge, where you might not be able to control your underlay transports, maybe a tactical environment, you're using 5G, SATCOM, transports that you necessarily don't control, and you're trying to unify that with an overlay. Great use case for SD-WAN. But when you get into the middle mile and the transport piece, you can have an SRv6 backbone there, and this is where we're working closely with Cisco. They've been doing a lot of innovation on this regard to be able to integrate the technologies together from a data plane where you can have a service and a routing policy span both technology domains end to end, and then the automation and orchestration wrappers up above that to integrate that policy between the two different technologies, all being automated and orchestrated, so it's not all that manual operational work to an operator to do that on their own. So there's two different integration options. This first one is what can be done today, and this is actually what PACAF is doing. We're implementing here at PACAF. So this, you have a SRv6 transport, kind of middle mile. the PACAF region that can support different mission partners, different classifications, kind of act as kind of a next generation Black Core. And then they're migrating, the Air Force here in the PAC is implementing for their NIPR capability is SD-WAN, which they're implementing Cisco SD-WAN. So we're working with rolling this out in the PAC for PACAF with the work and innovation from Cisco to integrate that seamlessly. So they have their NIPR services leveraging SD-WAN, but riding over an SRv6 underlay, which gives them a lot of cool capabilities that you wouldn't necessarily get from a traditional SD-WAN deployment. And be able to keep that routing policy and end-to-end, and the service end-to-end as well. So it's basically extending that SD-WAN fabric end-to-end over an SRv6 backbone. The second option, and this is something, there's actually some development code, beta code that's available to do this, but it's not fully available yet. But this concept of a SD-WAN to SRv6 gateway function, where you actually do a complete translation from an SD-WAN fabric into a SRv6, but again, maintaining that routing policy and that end-to-end service across the two. This really intrigued when we were talking with PACAF about this capability, is it allows SRv6, that I talked about earlier, where some of the MilDevs are evaluating 3 different SD-WAN OEMs. What if the tactical side chooses one, the enterprise side chooses one, and a couple of mission networks choose a different SD-WAN OEM? SRv6 can serve as a middle mile agnostic layer to translate between the different OEM SD-WAN fabrics. And this is a capability that this gateway function would allow that to happen. So in summary, I know we have to end here in a couple minutes, but one of the the marketing phrases I kind of like to use for this solution is this concept of local command and control, but globally interoperable. So with SRv6 and with the software-defined nature of it, and with SD-WAN, the ability to say, hey, you can prioritize your mission traffic over maybe NIPR traffic. If there's an event, you can easily, with this technology, round out like a NIPR service to give priority to your mission traffic. And that can be done at the local level, but then still be able to interoperate with any other mission partner with the openness of SRv6. The other thing is the simplification for the warfighters and being able to unify all your typically today disparate WAN transports together, be able to provide a warfighter out in the front lines connectivity and access to back to home station. So that is some of the true benefits that really get after, I think, some of the critical mission requirements that are out there across the different MilDevs. So in the last minute that I have, if you want to learn more, I actually authored a white paper. You can kind of take a scan and download it if you like on this topic. Also, we are kind of co-hosting with Cisco a SRv6 federal focus symposium in the DMV area. If you're in the capital region, it'll be at our headquarters in Reston, Virginia. If you're local there, you could, again, use the barcode there. You can register for it and attend that. And then, come talk to me at our booth of 1003, or reach out to us, and we'd love to dive in more. I've been talking about this with a lot of different MilDevs, Army, Air Force, had discussions with DISA. There's some interesting opportunities to leverage some of this innovation. So I thank you for your time, and I think we may have some time for a few questions if you have any. No questions?